So now let's look at applying secure principles to site and facility design. Now, a few things as a security professional that we need to think about when it comes to site and facility design or our physical design. Because this section is going to be all about physical security. What can we put in place to mitigate this, or what can we put in place to mitigate that? So first thing we need to do, we need to get a lay of the land, if you will. Do a security survey. We're going to go around the building. We're going to go around to our data centers, our comm closets, look in the hallways, talk to other personnel about opinions, get interviews. We need to look at the threats. We need to step back for a minute and actually think like an attacker. Think like a malicious user. What they would do if they was to see this building. You know, step back and say, well, I see this could happen. So now I know what the threats could be, right? I have to think about the assets that I'm trying to protect. I'm going to go around and say, well, you know, the building itself is an asset. The equipment we have is assets. The data that the equipment is holding is a major asset. All the personnel, IT folks, security folks, end users, they're all assets to the company. So how can we make sure that this facility, that this physical security is, well, it's secure? We're going to look at policies, see what the policies that we already have in place for the organization, see what they cover, what they don't cover. We're going to look for holes. Again, think like an attacker. I'm not telling you to be a bad person, but in order to understand your enemy, you have to think like them, right? You have to be them for a little bit. So we need to do that when we're trying to solidify our physical environment, our facility. Look at the procedures in the policies. If you know something is supposed to happen, right? Think of your disaster recovery plan. If we know something has happened, what is the policy for that, and who is supposed to take care of that, and how are they supposed to do it, the procedures of that. We're going to do a vulnerability assessment. Kind of goes along with our security survey. We're going to step back again and look for the weaknesses. Look for the possibilities of something happening. I do this every time. Every time I go to a different location for training, consulting, seminars, whatever. Even if I'm a student somewhere at a conference, and it's just habit because of teaching it, because of thinking about it, but I'm always looking and doing a security survey. I'm not walking around with a clipboard or anything, but in my head, I'm visually looking around. I'm looking for these weaknesses. For whatever reason, it's just ingrained in me. I look for security cameras. I look for door locks. I look for the boulders outside, you know, the big flower pot things that keep vehicles away from the facility for so many feet. I look at fences and gates. I look at access controls. You know, I'm looking at the lighting. I look at it from a hacker's point of view. Right? I want to see the weaknesses, especially if I'm teaching and it's their facility I'm teaching in. If we get to a point like this, I can give them a for instance, for example. I can say, okay, so think about your building for a second. Do you have security cameras outside? And if you do they point to the back door? Do you have just one out front? That would be a vulnerability, right? Do you have overhanging trees where I could get up in a tree and get on your roof? Maybe come through a skylight. Do you even have skylights? Where's your data center located? Is it on the edge of the building? Is there a window where I can get in to your comm closet? All things that you have to look for and think about. And it's really not like a 5-minute process here. You want to really go through and scrub through the physical security of your facility. It's super important. Physical security is one of my biggest pet peeves when it comes to security professionals, because we really think about the technical controls and the administrative controls more than we do physical controls. And I think that's not the way to go. Every job I've had, I've never been the IT director or the CIO or anything. I've worked for them or worked with them, and that's not on their priority. And I'm not saying everybody's like that. I'm not saying every security professional and IT professional does that. But the majority that I've talked to in the last 6 years of doing this, physical security is not the highest on their priority list, especially when it comes to IT. So these are things we have to think about. And we can employ other people to help us. Get custodial staff, the maintenance staff. They know a lot about the buildings. They know a lot about the facilities. Get them to help you. Those are the people you can survey, interview. Say, well, if this was to happen, what would be the response? What's the policy? What's the procedure say on what we need to do to fix this? And they'll tell you. Say, well, normally we do this. And so you think about it and then think like an attacker and think, well, if they did this, and then say, well, what if this happened? And they're, we don't know. So then you could come up with a procedure or put that in your survey, your vulnerability assessment, and say, well, we have a weakness here. This is something that we need to address. So it's a pretty big job so far on doing your site survey or your security survey and getting in and doing that vulnerability assessment. So again, you can think like the bad guy. Now, I went out because I am no a physical designer or facilities designer, and I looked at the American Institute of Architects. I mean, who knows, architecture better than the Institute of Architects? So I looked at theirs for principles on security design, and I pretty much just copied it right off of there because I thought they were all so good, right? They say facility security control during and after hours of operation. Makes total sense. Why would we not want security after hours? Yes, we normally think about it. People on hours, we have somebody on security watching people come in, watching people leave, checking the delivery folks that come in, and things like that, visitors. But after hours, if we just lock up the doors and leave, there's not as much security there. Yeah, you may have an alarm system. Yes, you may have locks, but facility security control, we need it all the time. Personnel and contract security policies and procedures. Again, we talked about that one. So policies and procedures, have those in place. Know who does what and when and why. Personnel screening, background checks for your personnel. Those pre-employment checks that we do, contacting references, right? Credit histories, criminal histories, things like that. So screen your personnel. Make sure you're not bringing in somebody that's like on a watch list or something like that. Site and building access control. So what kind of access control do you have in place for your building? Is it a public building? Or do you have to swipe your card to get in the front door? Swipe again to get into the office area? Swipe again to get into the server room or data center? Or none of the above? Video surveillance, assessment and archiving, CCTV, right? Do you have cameras in your facility? Do you have cameras outside or just inside or just outside or both? What areas are they monitoring? It kind of gets into privacy too, but public areas, office areas, it's fine to monitor those. How are you going to go through that and scrub that video? The assessment part. Usually it's more of a detective thing, right? We don't sit there and watch the video all day long. We use it, we archive it off somewhere for so long, 6 months, 12 months. And if something has happened, we can go back and use that as a detective control. Natural surveillance opportunities. If you're just naturally walking around, surveying, you're not using any cameras or hidden tricks or tactics. Protocols for responding to internal and external security incidences. So we have policies and procedures in place. The protocols of what we're going to do. Do you have an incident response team that jumps into action if something happens? Have a degree of integration of security in other building systems. Sure, great. Have your security alarm maybe set up with the fire systems. If the fire system goes off, it triggers a security alarm. Shipping and receiving security, right? All these vendors that you have coming into your facility. Do we have security? Is there some type of access control on them? Or can the delivery guy just walk in the building, say hello, and go up to the third floor where the data center is and do something malicious? And we don't know. You know, you may recognize him. You may not. Might be the new delivery guy. Who's to say I couldn't go get one of those uniforms, walk in there like I have a package to deliver to Mr. Smith on the third floor because I know that's where the data center is, and you just let me go on up. It's not very good security. So have property identification and tracking. Track your assets. We did that at one job I had. We had stickers, barcodes on every asset if it was over some certain dollar amount. And that way we could track where they were. Every time we moved them, that was part of our change management. They would get scanned. And then in the inventory and the tracking, we would put what room and building and things like that that piece of equipment was in. Have proprietary information security. Protect our personal data. Right? Proprietary information belongs to us. That's our company's data. Encryption would be pretty good on this one. Computer network security. That's probably a given, right? That's one of the first things we think about, that and proprietary information security with encryption, protecting our personal data. Workplace violence prevention. Do we have end-user training? Do we have on-site counselors? Do we have, policies in place that give people a break? You take away stress, relieve some pressure, right? A lot of corporations, you hear about these big corporations, they've got gyms and they've got open area seating, and some of them, I can't remember what the company was, I'm talking about these tech companies out west, but they'll have like the slide, right? A spiral slide inside to go from like the second floor to the first floor, for example. Kind of let people relieve some stress a little bit, especially if they're getting really at it for you. They're making your company money. Do a little something for them on the back end, right? Mail screening operations, procedures and recommendations. Kind of goes along with the delivery folks, right? The shipping and receiving security when those vendors are coming in. Parking lot and site security. Do you have cameras pointing out in the parking lot? Are you surveying the parking lot? Do we have adequate lighting in the parking lot? Is there a gate? Is there some type of control before the parking lot? Or is just all the control right at the building? Executive protection. Are we protecting executive items, executive data, the executive themselves? Communication security. Are we protecting our communications with encryption? How is the data being protected? And then we're always going to have that business continuity plan, that BCP, and evacuation procedures, a disaster recovery plan. All of these are going to be in our BCP, our business continuity plan. So you can see, I really like these. I think they're, if it's not the know-all, be-all, but it's a very, very good starting point when you think about your physical security and your facility design to, and I'm not saying these are guidelines, but these is what they do, right? And they're pretty good ideas out there that I think would be a really good starting point for your facility design. Now, what about designing and implementing physical security for specifics? Like first off, the wiring closets, your comm closets, or your server rooms. We really have to think about where they're going to be in the facility for one. You may need to be part of the facility design. If the building's already there, and let's say you moved in, then the planning portion, we really need a security professional in there, a security practitioner, somebody from IT, something that somebody knows about this when it comes to where data centers will be located in a facility, where comm closets will be located, or server rooms. They can't, well, they can, but we don't want them on the edge of the building. We don't want them to have windows. We can't have them accessible from the outside like that. It's hard enough to protect them on the inside, much less having them on an outside wall and a window at that. So think about the entrances of how to get to these locations. Do we have just one? Be best idea. You don't want to have 3 doors to your server room. That's more opportunity. Think about, we've talked about ports on a computer, the ways to get in a computer. Well, these could be ports to the server room. One entrance, we only have one we have to protect and guard. What about lightning protection and grounding, right? Or is the building secure? If the building gets hit by lightning, or if your data center gets hit by lightning, is it going to be grounded properly? Or are you going to lose thousands or millions of dollars of equipment due to a lightning strike? Access control, huge one when it comes to your server room and comm closets or wiring closets, whatever label you want to give it. Who has access to get in there? What type of locks do you have? Do you have the cipher locks? Do you have biometric locks? Do you have key card scanners? Do you have just a key, a regular key, just like you do probably on your front door, right? Put the key in and turn it. Who's controlling that key? Can you make copies of those keys? Things like that. We have to think about all of this when it comes to physical security. What about your rack security? All right, who has access to the racks? And let's say you have half a dozen people on the IT team and they have access to the server room. And that's fine. They have legitimate access to the server room. But you've got a web developer in there that takes care of the web server. You may have a system admin that takes care of your directory services and DNS. You may have a backup operator that just messes with the backup servers over there. So, do all of these people need equal access to the other servers? Probably not. The server admin, maybe. The backup operator, he doesn't necessarily need access to all of them. Just his backup machine or backup servers or where his data is kept. The web services manager doesn't necessarily need access to everything either. So can we lock down those racks? You know, some racks are wide open. Some of them have the cages. They're in the small cages, right? Can we lock those down? Also, your rack security, when it comes to physical security, are they installed properly? Are they bolted to the floor and bolted to the ceiling and attached to the wall? If something was to happen as far as earthquake, hurricane, something that's making it shake, if somebody ran into it, would the rack fall over? Is it installed properly? Got to think about HVAC a little bit too, our heating and air. We don't want our server rooms and our wiring closets, our comm closets, getting too hot. Heat is not good for servers. Heat is not good for our electrical equipment. On the flip side, being too cold in there is not good for them either. We want it kind of cool, right? 60, 65 degrees. Now that might sound a little chilly for a human, but we're not hanging out in there. This is not the break room. But this is a really good idea for your electrical equipment because you do need to keep it somewhat cool, but we don't need icicles hanging off the servers. Something else, and we'll talk about it a little bit later when we get to utilities, is humidity control. Keep that in mind till we get there. What about media storage? All right, think about your media. Like I talked about the backup operator. Well, where is he storing that media? Maybe he has backups on tapes or DVDs. What is he going to do with those? Or what is she going to do with those? Are they going to just set them beside the server, which I've seen many times? They back up the server, put it on the tape, and they set the tape right on top of the server they just backed up. Not the best idea. What should we do with this media? Where should we store it? How should we store it? Put it in an anti-static bag, maybe? Put it in a safe somewhere? Not a bad idea. Fireproof? Separate building altogether, maybe? At least a separate room. Separate building is even better. Maybe off-site location is even better than that. So we have to think about where we're storing all this media because media holds our data. Our data is supposedly supposed to be important to us, right? That's our assets, or one of our assets. So we need to make sure we're safeguarding this information. What about evidence storage? If you ever have to do forensics, what are you going to do with these devices? Well, you could use something like the Faraday bags, right? You go get these, say you grab a device, and so it can't receive or send any more signals. You stick it in the Faraday bag, right? Seal it up, and it should not be able to communicate anymore. So that would be one way to store your evidence. We need to make sure once you collect that and you put it in a secure location, access control really needs to be in play here. Only authorized people need to be able to get to the evidence. You probably need some type of camera system inside the evidence room or wherever you're storing this evidence. Because if somebody can compromise that evidence, you're going to lose whatever case you had against this malicious person or disgruntled employee. Because now you can't prove it. Somebody has tampered with the evidence. And that's bad. That's terrible. We don't want that to happen. So evidence storage, we need secure rooms, secure cabinets, secure safes. This needs to be locked away. We need continuous monitoring, logging control of who goes in and out of this evidence storage area. We need good fire suppression in there. Probably not a liquid. What else? Good heating and air. Things like that. Heating and air always. But these are things we have to think about for evidence because we need to make sure it's protected. Restricted areas. An evidence storage could be a restricted area. Highly restricted areas may go above and beyond. You may have sound protection in the walls. You may have something that generates white noise. So like anybody outside, in addition to the sound protection we have in the walls, the white noise kind of drowns out any conversations, confidential conversations that may go on inside of this restricted area. You may have monitors for radio waves that may be broadcasting information or snooping devices where they're trying to pick up sound waves out of this restricted or highly secured area. You probably have walls that are true walls. They go from the floor all the way to the ceiling, not just up in the ceiling where now the drop ceiling comes down. So you have a wall here and the drop ceiling's here. But if you move the tile, then you can just go up and over the wall and get to the next room over. You don't have that in restricted or highly secured areas. It will be a true wall from floor to ceiling. The vents, the heating and air vents, they may have bars inside of them to prevent individuals from climbing through the ducts. Now, I know this sounds like it's movie-type spy stuff, but these restricted areas, they have this kind of stuff, okay? I'm kind of thinking of like a SCISSP it's a highly secure area in the military, right, where they do top secret networking stuff, and they have controls like this in place where they're protecting this facility a lot. They have very controlled access in who can get inside of this area, this restricted area. They've got armed guards in some of these places where they will not let you get close to this facility, and I really wouldn't test them either. What about your data center? Now, all of the above that I've talked about so far could go for your data center. The entrances, the lightning protection, access control, rack security, HVAC is important again. That humidity control, we're going to talk about that in a second. But in addition to your data center, I mean, you may not have the armed guard outside, but you still want the true walls, all right, floor to ceiling, all the way to the roof, right, not just to the drop ceiling. You want to make sure you maybe have proximity cards or some type of access control scanned entry. cipher locks maybe. But with the proximity control, now you have more accountability, because with that, even though they had to cipher lock in, everybody might know the cipher lock combination. And I say everybody, all the authorized people. But that doesn't differentiate between you and me. But with a proximity card or a proximity device, now they can track who is in that facility and where they went in that facility. They have time stamps and date stamps now. You're probably going to have some closed circuit television in there to record who's coming in and out of the one entrance. So again, you can have accountability and security. You may have a man trap where you walk in a secure area, one door opens, you walk in, it closes behind you, and now the next one will open. That prevents tailgating, right? People walking in behind you, because it's going to be about big enough for one person. All right, and it's usually glass, so you don't get, it's not like a tube that you walk in and get claustrophobic. But I've seen them where it's kind of tight, but you walk in, it closes, and then once it closes, you may get authorized again or authenticated again. You may have to weigh a certain weight, right? When they registered you and you said, well, I weigh 200 pounds. Well, and now you're at 175. Well, you may be somebody else, and it may not register you properly. And then it's going to trap you in this man trap where you can't get out until security personnel arrive. So anyway, it closes behind you, it opens the next one, and you can enter the data center. And now these scenarios I'm painting, right? Yeah, I may be going above and beyond what most data centers have, but don't think they're not out there. There are some highly secure data centers, and there are some data centers where it's just one lock and you with a key and you can walk on in. Now, some of this stuff is a given. Rack security, I would hope people strap that stuff down, bolt it down, make sure it's secure. HVAC, I can't say that's a given because I've been in some comm closets where I know it's every bit of 80 or 90 degrees in there because they don't have the proper cooling in there. So they'll pop open the ceiling tiles to let the heat out, and they'll have a fan blowing through maybe to try to circulate that. So things like that is common, is very common, and I understand that. So don't think you have to go get a man trap, and if you don't, you're doomed. And I'm not trying to act like a spy either, but these are out there. I'm not making this stuff up. What about utilities and HVAC considerations? Right? Most of the time, we've had UPSs for a while, an UPS, right? Or an uninterruptible power supply, right? It's the battery pack sitting on the floor that if the power goes out, it will keep your server on or keep your workstation on or keep your laptop going until you can shut it down gracefully. It's not like it's going to run it all day and night until everything goes. Depending on the UPS size, I guess I should say, most of the ones you get for your desktop servers, it'll keep them going for 30 minutes, 45 minutes, an hour maybe. That allows you to get there and shut it down properly so you don't have data corruption and broken sessions and just bad things that could happen by just jerking the power out of your server. All right, we don't want to do that. So employ some UPSs around. You could have big ones. Comm closet I used to work in, or a building I used to work in, had a UPS probably about this wide, probably about this tall. It was huge, but it ran the whole server room that we had, about 8 servers in there and a workstation. And it would keep them going probably for about 4 or 5 hours. Enough time for somebody to get there and take care of everything, or hopefully the power would come back on by that time. Or you could have generators. If it's not an option for you to be down at all, you could have UPSs, inline UPSs, and generators on the back end. Because sometimes, let's say the power goes out. Well, what's supposed to happen is that security system is supposed to kick the generator on and say, okay, hey, it's time to come on. We've lost power. But it takes a second, right? There's a motor in there. It's got to start up. It's got to start the generating process, and then electricity will start coming through. So you may be down for 15, 20, 30 seconds until that can kick on. That's why you want an inline UPS, that battery power, to give you that time for the generator to start up. So put those in line. And you may have diesel power generators, natural gas generators, whatever kind of generator you have. But once the generator starts, right, then it could power the building or power your data center so you're not down. And sometimes you have to have that, right? If you're a service provider, and let's say you have the SLAs, right, service level agreements, and you say, I'm going to be up the 5 nines, 99.999% of the time. Well, that only gives you about a 25, 30-minute window every year. So you couldn't be down for 30 minutes, an hour a day. It's not going to work out too well for you. You're going to start losing customers and reputation. So you're going to have something like that. And then humidity control for our HVAC. We talked about the heating and air, right? We don't want it really hot. We don't want it really cold. But we also don't want it very wet in there, right? If you water and electricity or electronic components, they don't mix very well. If it's too wet in there, we could start to have corrosion. We could start to, you could have electricity. I mean, you could have water damage, right? You could start to have water issues if you get it too humid in there. It means there's too much water in the air, too much moisture. So you can have dehumidifiers in there, and it would pull the water out of the air, the moisture out of the air. But we have to be careful with that as well. We don't want to have it too dry in there, because in dry environments, then you're more prone to static electricity. So when somebody walks into the server room and they reach up to do something on the server, they're going to zap that server. Now, yes, we could wear the anti-static wrist mats. We could short ourselves out on the rack. We could have the static electricity mat of when we walk in. But let's say we don't. Humidity control is great, all right? Keep it about 30, 40%, everything should be fine. 30, 40%, 65 degrees, everybody's happy. Leads into water issues like flooding or leaks. How are we going to deal with that? That's going to be in your disaster recovery plan, right? A flooding shouldn't be a problem. Because, and I say this, it depends on what kind of flood you have, but you don't want your data center, your comm closets, your wiring closets, your server rooms, you don't want them on the first floor necessarily because of this very thing. Now, if you live in an area that's very prone to flooding, make sure you're at least on the second floor. Right? If you don't think you got much problem for flooding, first floor might work, especially if you only got a one-level building to work with. But we want to make sure we're above floodplains. Get your equipment up as high as possible, even if it's just a raised floor on the first floor. That's going to give you 12, 18 inches to work with. Leaks, we'll have to deal with those as fast as possible, right? That could be a bad issue when it comes to electronics. And we talked about water and electronics mixing. All right, so any leaks, we need to make sure that we monitor for those. All right, we're going to do that. You could do that on our security survey. You could have monitors in place that monitor for that type of activity as well. And then the fire prevention, detection, and suppression. All right, we want good prevention, detection, and suppression. So let's take a look at some of these here for our fire prevention and suppression. You could have a wet system. Now, these are the little things that you see up in the ceiling, right? The little sprinkler heads that you may see. A wet system, those pipes are ready to go. They have a constant supply of water in them at all times. Now, once they're activated, the sprinklers are not going to shut off until you go shut it off at the main, right? It's not like it's just going to blast for about 5 minutes and be done, or blast for a minute and be done. Right? These are connected directly to your water main in your facility. So you're going to have to shut that off, crank that wheel to get those to turn off. You may have a dry system. Now, these don't have water in them at the go, right? So the valve will not release until the electric valve is stimulated by excess heat. So there's going to be somewhat of a delay, right? We have a pre-action system. Now, this one incorporates a detection system, which could be part of that security system. Now, this can eliminate concerns of water damage due to false activations. So if somebody hits it, right? In a wet system, if I was to reach up there and hit it accidentally, or if somebody's walking with a ladder and they hit it, it's going to activate. And that one sprinkler head's going to go crazy with water, right? It's going to start gushing out until we run down there and turn the water main off. A pre-action system wouldn't do that because it didn't detect it, right? It's not, it did, but it didn't detect it. It detected that it got hit, but it didn't detect excessive heat, right? Unless you're holding a match or a lighter or something up there, and then you could set it off accidentally. And then the deluge systems, these operate kind of like the pre-action systems, except all the sprinkler heads are already in the open position. So it doesn't wait for excessive heat. If you have a detector, right, and that detector detects the heat, all right, some type of monitoring system, then it's going to kick off onto the watering system and start piping it through. And we don't have to worry about these being on or melt or anything before anything happens. So that's a few fire suppressions that we need to be aware of when it comes to our facilities. So that does it for Domain 3. We covered quite a bit in here. We talked about implementing and managing an engineering lifecycle using security design principles, the fundamental concepts of our security models, talked about controls and countermeasures based upon information systems security standards, standard or security capabilities of information systems. We talked about assessing and mitigating the vulnerabilities of security architectures, designs, and solution elements. We talked about the vulnerabilities in web systems, the vulnerabilities in our mobile systems, the vulnerabilities in those embedded systems, a little bit about cryptography, apply security principles to site and facility design, and finally wrapped it up there with that facility and physical security.